and we're talking about angles of elevation and depression. And when we're talking about, so what angles of elevation, angles of depression are just different ways of describing particular kinds of angles that we can use when we're solving problems. So let's talk about the angle of elevation first. So just thinking about those words, angle of elevation. What would you guess when we're thinking of elevation? What do we think of? Up. Elevation has something to do with up. Well, that's how we're going to describe our angle of elevation. It's the angle up from the horizontal. So that's going to be our angle of elevation. Horizontal, what when I say horizontal, what do I mean? What's that? Just in general, if I say something's horizontal, what am I talking about? Which direction is horizontal?
No, side to side.
Side to side. Horizon, think horizon. Horizontal, side to side. So we're thinking horizontal means level, side to side. So it'd be like on the ground, basically. Ground level. Horizontal, think horizon, side to side. So if I'm going to draw my horizontal, a dotted line for my horizontal. So there's the horizontal, side to side. And the angle of elevation goes up from the horizontal. So that would be an angle of elevation. So that's all we're talking about when we're talking about an angle of elevation. Angle of depression. So when we think of angle of depression, what direction do you think we're talking about when we're talking about angle of depression? Down. If we have a depression in the road, it means there's a dip in the road, it goes down. You hear they call hurricanes a tropical depression because the pressure is low. Talking about down. So we're going to say our angle of depression is the angle down from the horizontal. So here's my horizontal again. Draw a dotted horizontal. And the angle of depression goes down from the horizontal. And that's my angle of depression. So what we're going to do with angle of elevation, angle of depression, is we're going to use these two things to set up problems that have to do with right triangles. So the first thing I want to do is I'm going to draw a picture, and we'll pick out which angles are angles of elevation, which angles are angles of depression, and then we'll use that idea to set up a couple of problems. In this chapter, and in fact in all geometry problems, if they don't give you a picture, draw a picture to help you out. So we'll end up drawing pictures for our problems for these trig problems. But in general, if they don't give you a picture, draw a picture to help you out solving the problem. So let's do a couple of examples. So for this one, we have a air traffic control tower. So here's my control tower. And in the control tower, the people in the control tower are looking at an airplane. and they're looking at a ground crew. So here's my airplane. And here's my ground crew. And I'm going to draw in the horizontal lines in several different places. So that one's a horizontal. That dotted line would be a horizontal. That dotted line would be a horizontal. So all my dotted lines are the horizontal lines. And I'm going to call these angles 1, 2, 3, and 4. And what we want to do in this example is decide whether the angle is an angle of elevation or an angle of depression, and say where does it go from and where does it go to. So, angle 1. Is angle 1 going to be an angle of elevation or an angle of depression? Depression, where the plane is looking down towards the tower. Angle 1 is angle of depression. And we're going to say from the plane to tower. And that's how a problem might describe that angle. The angle of depression from an airplane to the control tower is 23 degrees. And they'd be talking about this angle. How about angle 2? Angle 2 going to be an angle of elevation or an angle of depression? Elevation, because in the tower they're looking up from the horizontal to the airplane. It'd be, I guess once the plane lands, they could look down at the airplane. In general, you're hoping they're looking up from the tower to the airplane. So this is going to be an angle of elevation. From the tower to the plane. And the problem might describe it that way. The angle of elevation from the control tower to the plane is 73 degrees. How about angle 3? Is angle 3 going to be an angle of elevation or an angle of depression? Depression, because the tower, from the tower they're looking down at the ground crew. So this is going to be an angle of depression from the tower to the crew. And in a problem, that's how they would describe it. The angle of depression from the control tower to the ground crew is 19 degrees. And finally, angle 4. Angle 4 going to be an angle of elevation or angle of depression? Elevation. And this is from the crew to the tower. So our angle of elevation is always going from the horizontal. Up from the horizontal for elevation, down from the horizontal for depression. Alright, so these horizontal lines, these dotted lines, what do we know about them? How are the horizontal lines related to each other? They're all horizontal, so they're all going to be parallel, right? So the horizontal lines are all parallel. Since they're all horizontal, they're all parallel. What does that tell us about angle 1 and angle 2? They're congruent. Angle 1 is congruent to angle 2. What kind of angles are these for these two parallel lines? They're on opposite sides of the transversal, and they're between the parallel lines, so they're interior angles. Alternate interior angles. Angle 1 and 2 are alternate interior angles, so they're congruent. How about angle 3 and angle 4? They're also alternate interior angles, so that tells us that angle 3 is congruent to angle 4. And that's because they are all alternate interior angles. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Horizontal lines are parallel, so those alternate interior angles are congruent. So we can use that sometimes to help us solve problems, that these two angles are going to be congruent. Questions on this part? Okay, let's use these ideas to set up a couple of problems. So in our first example, we want to figure out how tall a tree is. We like figuring out how tall trees are in this way. So Kyle is in the forest. Kyle is 120 feet from the base of a tree. The angle of elevation from eye level to the top of the tree is 40 degrees. And Kyle happens to know that his eyes are 5 feet above the ground. And we want to know how tall is the tree to the nearest foot. All right, so let's draw a picture. So the last time we were measuring a tree, I think we had a mirror, and we used similar triangles to measure this tree. So here's my tree, and here's Kyle standing over here. And here's the ground level. And it says the angle, and we know he's 120 feet from the tree. So this, we know that's 120 feet. And we're assuming here that the tree is growing perfectly vertical. So this is a 90-degree angle. All right, it says the angle of elevation from eye level to the top of the tree is 40 degrees. So where am I going to draw my line that shows the angle of elevation? From his face, from his eyes, to the top of the tree. And the angle of elevation goes up from the horizontal. So there is my horizontal. So it tells me that this is a 40-degree angle. And it tells us that the eye level is 5 feet. So what we're going to do here is use trigonometry on this triangle from his eye level, and we're going to find x here. Now, does x tell us the height of the tree? No. What do we have to do when we're done to find the height of the tree? Add 5 feet, because eye level, the horizontal that we're talking about, is 5 feet above the ground. So we're going to find x and add 5 feet. Well, this is 120 feet on this side. This is x. So now we can use trigonometry to solve this problem. So we're going to label our triangle. X, opposite, adjacent, or hypotenuse to this 40-degree angle. Opposite. And the 120 feet? adjacent. And then we go to SOHCAHTOA and we say what trig ratio tells us about the opposite and the adjacent. If it helps us out, we can write it up here. Tangent. Tangent tells us about the opposite and adjacent. So I'm going to write my equation. Tangent of 40 degrees equals the opposite, x, over the adjacent, 120. I want to get x by itself. I want to solve for x. So what do I do here? Multiply by 120. Those cancel. So I get x equals 120 times the tangent of 40 degrees. And plug that in my calculator. And I get x equals 100.69. And we decided we had to add 5 feet to get the height of the tree. So the tree equals 100.69 plus 5. 105.69. And the problem says round to the nearest foot. So the tree, for my answer, I'm going to write, how am I going to round this to the nearest foot? 106. So Kyle didn't have a mirror this time to use similar triangles, but he had his calculator, so he could find tangent of 40 degrees, and he was able to figure out that the tree is about 106 feet tall. Questions there? So once we drew our picture, then we're just back to using SOHCAHTOA and finding parts of triangles. All right, let's look at another example. This one we have to be a little more careful. It's not much different. So for this one, we have a lighthouse. And our lighthouse, the observation area, the place where you can look at a lighthouse, is 175 feet above ground. The angle of depression to a ship is 62 degrees. We want to know how far is a ship from the base of the lighthouse. And we want to the nearest foot. So let's draw a picture. They don't give us a picture here. So here's my lighthouse. Nice lighthouse there. And it is, they tell us it's 175 feet tall. And my ship is out here in the water somewhere. So there's my ship. And it says the angle of depression from the lighthouse to the ship, so I'm just going to draw it like that, is 62 degrees. Is this the angle of depression? Is that where they're saying it's 62 degrees? No?
It's where this
So the angle of depression goes from what? down from the horizontal. So we need to draw a horizontal line in here. So where they're seeing it, let's draw in our horizontal. There's the horizontal. This is where people are usually going to make a mistake on this type of question. They want to say this is the angle of depression. That is not the angle of depression. The angle of depression is down from the horizontal. So this is going to be my 62-degree angle. And we want to find this distance here. So what we're looking at is a triangle that looks like so. And our lighthouse is not leaning, so that's a 90-degree angle. So that's what we're looking at there. All right. Yes. Oh, question? Or are you just stretching? All right. So we need our angle inside the triangle to use trigonometry. So we can do it a couple of ways. How could we find this angle if we wanted to use it? What is this whole angle? 90 degrees. That's a 90-degree angle. So we could find the angle inside the triangle by subtracting 62 from 90. So we could do it that way. But where else do we know we have a 62-degree angle? By the ship. We've decided that these two angles, this angle and this angle, are alternate interior angles. So that's also 62 degrees. So the angle of elevation from the ship to the lighthouse is also 62 degrees. Now we're set. Now we can use trigonometry and find this missing piece. So for the 62-degree angle here, is x the opposite, the adjacent, or the hypotenuse? That's our adjacent side. 175 feet, opposite, adjacent, hypotenuse. Opposite. Now we can write our equation, which trig ratio tells us about opposite and adjacent. Tangent. So if it helps you out, you can write this up. Whoops. So we're talking about opposite and adjacent, so we're talking about the tangent. So we write our equation. The tangent of the angle, 62 degrees, equals 175 over x. So we know how to do these. We did several of these the other day. How do we get rid of this x in the bottom? Multiply everything by x. Those cancel. And I get x tangent 62 degrees equals 175. And we could turn tangent 62 degrees into a decimal here and use a decimal. If you do that, remember to keep 4 decimal places. Most of us can put it in our calculator just like we write it. So I'm going to divide by tangent of 62 degrees. Those cancel, and I get x equals 175 over the tangent of 62 degrees. Plug that in my calculator, and I get x is about, in my calculator says 93.05, 93.05. I'm going to round that to the nearest foot. So how do I round this? 93 feet. So this type of problem is where students are usually going to make a mistake. If you're going to make a mistake, is where you put the angle of depression. The angle of depression always has to go down from the horizontal. Draw in your, if you're not sure, draw in your horizontal. Go down from the horizontal for angle of depression, or up from the horizontal for angle of elevation. All right, questions on that problem? Homework tonight, more or less problems, all problems that are similar to these last two that we did, thinking about angles of elevation, angles of depression. So, page 519 is where we are.